the volume of air inhaled is the same as the volume of air exhaled. This volume is called the tidal volume, or TV, and is typically about 500 milliliters. To analyze the results, read the volume of air moved on the y-axis. The tidal volume does not represent all of the air that can be moved in and out of the lungs. Additional air can be inhaled and exhaled. To measure the additional volume of air that can be inhaled, breathe in as much air as you can through the spirometer. This additional volume of air beyond the tidal volume is called the Inspiratory Reserve Volume, or the IRV, and is typically about 3,100 milliliters. To analyze the results, read the volume of air moved on the y-axis. To measure the additional volume of air that can be exhaled, inhale normally. Then, exhale as much air as you can into the spirometer. This additional volume of air beyond the tidal volume is called the Expiratory Reserve Volume, or the ERV, and is typically about 1,200 milliliters. To analyze the results, read the volume of air moved on the y-axis. The forced vital capacity is the total volume of air that can be moved in and out of the lungs. It is the sum of the tidal volume, the IRV, and the ERV. To measure the forced vital capacity, take the biggest inhalation possible, then exhale everything you can into the spirometer. The forced vital capacity is typically around 4,800 milliliters. To analyze the results, read the volume of air moved on the y-axis.
The forced vital capacity is the same as vital capacity.
Even after we exhale all the air we can, our lungs aren't empty. There is still a volume of air that remains in the lungs, called the residual volume. The residual volume can't be measured with a spirometer. It is a calculation based on sex, height, and age. It's typically about 1,200 milliliters. As you can see, there are many different types of spirometers, but they all share a similar purpose and use.
This is a spirogram, which is just a graph of the recording made by a spirometer. And so you can see in this column where they're looking at volumes, these are the volumes that can be measured on a spirometer. The tidal volume is the amount of air that a person is inhaling and exhaling. That should be an equal volume. The amount of air that they can inhale in addition to what they usually do, the IRV, the Inspiratory Reserve Volume. The amount of air that they can exhale in addition to what they usually exhale, and that's the ERV, the Expiratory Reserve Volume. And then this is the only volume that can't be measured on a spirometer. The residual volume is the amount of air that remains in the lungs even after a person exhales everything that they can. Even when we do that, we still have air that remains in the lungs. And so these are the volumes that we can measure. The residual volume we calculate. And looking further on this graph, you can see that what they're talking about over here is a capacity. And if you're looking at a capacity, you're looking at an equation. Okay, so it's not, one item, it's a combination of these smaller volumes. And so the functional residual capacity, for instance, would be the amount of air that remains in the lungs after a normal quiet exhalation. It would be the sum of the ERV plus the residual volume. Another common measurement is the vital capacity. And the vital capacity is everything that you're in conscious control of. So if we breathe in as much air as we can, the IRV, and then exhale that, the TRV, and the ERV, this is everything that you can, consciously move in and out of your lungs. That's the vital capacity. Of course, the vital capacity isn't the full amount of air that your lungs can hold because of this residual volume. And if you add the residual volume onto the vital capacity, that's what's known as the total lung capacity. The total lung capacity would be what we're in conscious control of, the IRV, the TV, plus the ERV, plus the amount of air that we're not in conscious control of, the residual volume.